Alright, so now let's move on and look at our next algorithm, which is the K nearest neighbor algorithm. Now, KNN, which basically stands for K nearest neighbor, is again a supervised classification algorithm that classifies a new data point into the target class or the output class depending on the features of its neighboring data points. Right? That's why it's called K nearest neighbor. So let's try to understand KNN with a small analogy. Okay, let's say that we want a machine to distinguish between the images of cats and dogs. So to do this, we must input a data set of cat and dog images, and we have to train a model to detect the animal based on certain features. Okay, for example, features such as pointy ears can be used to identify cats, right? Similarly, we can identify dogs based on their long ears. So after studying the data set during the training phase, when a new image is given to the model, the KNN algorithm will classify it into either cats or dogs depending on the similarity in their features. Okay, let's say that a new image has pointy ears. It will classify that image as cat because it is similar to the cat images, because it's similar to its neighbors. In this manner, the KNN algorithm classifies the data points based on how similar they are to their neighboring data points, right? So this is a small example. We'll discuss more about it in the further slides. Now, let me tell you a couple of features of KNN algorithm. So first of all, we know that it is a supervised learning algorithm. It uses labeled input data set to predict the output of the data points. Then it is also one of the simplest machine learning algorithms, and it can be easily implemented for a varied set of problems. Another feature is that it is non-parametric, meaning that it does not take in any assumptions. For example, naive Bayes is a parametric model because it assumes that all the independent variables are in no way related to each other, right? It has assumptions about the model. K nearest neighbor has no such assumptions. That's why it's considered a non-parametric model. Another feature is that it is a lazy algorithm. Now, lazy algorithm basically is any algorithm that memorizes the training set instead of learning a discriminative function from the training data. Okay. Now, even though KNN is mainly a classification algorithm, it can also be used for regression cases, right? So KNN is actually both a classification and a regression algorithm. But mostly you'll see that it will be used only for classification problems. The most important feature about K nearest neighbor is that it's based on feature similarity with its neighboring data points. All right, you'll understand this in the example that I'm going to tell you. Now, in this image, we have two classes of data, right? We have class A, which is squares, and class B, which are triangles. Now, the problem statement is to assign the new input data point to one of the two classes by using the KNN algorithm. So, the first step in the KNN algorithm is to define the value of K. But what does the K in the KNN algorithm stand for? Now, the K stands for the number of nearest neighbors, and that's why it's got the name K nearest neighbors, right? Now, in this image, I've defined the value of K as 3. This means that the algorithm will consider the three neighbors that are closest to the new data point in order to decide the class of the new data point. So the closest between the data point is calculated by using measures such as Euclidean distance and Manhattan distance, which I'll be explaining in a while. So at k is equal to 3, the neighbors include two squares and one triangle. So if I were to classify the new data point based on k equal to 3, then it should be assigned to class A, correct? It should be assigned to squares. But what if the k value is set to 7? Here I'm basically telling my algorithm to look for the 7 nearest neighbors and classify the new data point into the class it is most similar to, right? So at k equal to 7, the neighbors include 3 squares and 4 triangles. So if I were to classify the new data point based on k equal to 7, then it would be assigned to class B since a majority of its neighbors are from class B. Now, this is where a lot of us get confused, right? So, how do we know which k value is the most suitable for k nearest neighbor? Now, there are a couple of methods used to calculate the k value. One of them is known as the elbow method, right? We'll be discussing the elbow method in the upcoming slides. Okay. So for now, let me just show you the measures that are involved behind KNN. Okay, there's very simple math behind the k nearest neighbor algorithm. So I'll be discussing the Euclidean distance with you. Now, in this figure, we have to measure the distance between P1 and P2 by using Euclidean distance. I'm sure a lot of you already know what Euclidean distance is. It is something that we learned in 8th or 10th grade, I'm not sure, right? So all you're doing is you're extracting x1. So the formula is basically x2 minus x1 the whole square plus y2 minus y1 the whole square. And the root of that is your Euclidean distance, right? It's as simple as that. So Euclidean distance is used as a measure to check the closeness of data points, right? So basically KNN uses the Euclidean distance to check the closeness of a new data point with its neighbors. So guys, it's as simple as that. KNN makes use of simple measures in order to solve very complex problems. Okay, this is one of the reasons why KNN is such a commonly used algorithm.